is on exponent rules or exponent properties. This last property we're going to look at is negative exponents. If a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. So again, it's when the value goes across the fraction bar, the sign of the exponent is changed. Nothing else, only the sign of the exponent. So when we're doing this, we have to understand that we'll have negative values in our problem, and this negative exponents does not include negative coefficients. So I'm going to make a note that negative coefficients negative coefficients aren't moved. Only negative exponents. So we have to be very careful about recognizing the exponents and the negative aspect of those. So if we look at our properties here, we have x to the negative m. Now that negative m is an exponent, and that is a negative exponent. We're not allowed to keep negative exponents. So what we do is we take what this is attached to, the factor is attached to the x. This entire thing will move to the bottom of the denominator, or to the bottom of the fraction bar, and the exponent changes signs. Nothing else changes. Now, because this moved to the bottom, there has to be something in the numerator. So we have to have a numerator and denominator. You should be able to figure out the numerator and denominator of any problem. If you do not have a value in the numerator, because when this moved, there was nothing up there, there is always an invisible 1. Remember the invisible math, if you don't see a number, it will generally be a 1. On this next one, we have x to the negative m in the denominator. So because this m is the exponent and it's negative, the factor it's attached to, which is just the x, all of that entire factor moves to the numerator up here with the 1, and the exponent changes signs. Nothing else changes. So that m becomes a positive m. Now, this next part of the negative exponent property is part of the expanded power rule as well. And you can do this property with the expanded power rule by putting the negative m to the exponent of the x and to the exponent of the y, and then you can flip everything. Or, because this is the exponent on the outside of parentheses, everything inside the parentheses flips. Now, nothing changes signs. All we do is take the denominator and it moves to the numerator, and the numerator moves to the denominator. And then the exponent on the outside changes signs. And again, you do not have to do this with this property. You can utilize the expanded power rule. So let's look at some examples with numbers in it. Example A, we have x to the negative 3. Now, we have to make sure that we understand how to rewrite this. This is really 1 times, because we do need to see the coefficient, x to the negative 3. Because we don't see an actual coefficient, we do need to make sure we show that this is a 1. Now, we find the negative exponent, which is the negative 3, and what it's attached to is just the x. It is just attached to the x. Now, this negative 3 is a negative exponent, so we're not allowed to have that. So we take this entire factor and we move it across the fraction bar. Well, there is no fraction bar currently, so what we're going to do is put a fraction bar. So this x to the negative 3 has to move across the fraction bar, so it was in the numerator, now it goes to the denominator. Everything stays the same except the exponent turns into a positive 3. That's the only thing that changes. Now, what stayed in the numerator? The 1 we never touched, we never circled it because it did not have a negative exponent, so that stays in the numerator. So then we can simplify this as 1 over x to the third power. And that is our simplification. Because this is a coefficient of 1 times x to the negative 3, that's why that 1 does need to stay in the numerator. It was that invisible math. Okay. On question B, this is 4 to the negative 2. Now, again, this has a negative exponent, and it is, in fact, attached to the 4. So what is the actual coefficient? The 4 is a factor. It's that factor of that negative 2. So we do need to rewrite this so that we can see a coefficient of a number times this piece. This is really 1 times 4 to the negative 2 power. Because we do need to have that multiplication, that 4 is what's attached to the exponent. We need a coefficient multiplied to that base. That 4 is the base of the exponent, so we do need to know what the coefficient is. Now, with this, we have a negative 2 exponent, and it is attached to just the 4. So this 4 to the negative 2 is what needs to move across the fraction bar. Nothing else does. And again, we have no fraction bar, so we write a fraction bar. Currently, this is all in the numerator because it's not in the denominator. So we move this 4 to the negative 2 below the fraction bar, so it becomes a 4, because the base stays the same. We always keep the base the same. And then we change the exponent to a positive 2. The numerator has nothing in here, so what remains? The 1 was never touched because it never had a negative exponent, so that 1 stays in the numerator. Now we have 1 divided by 4 to the positive 2 power. This we can simplify. 4 to the positive 2 power is really 4 squared, which is 16. So we can rewrite this problem as 1 over 4 squared is 16. Remember, when the base is a number and the exponent is a number, you should simplify that to its value. You should evaluate it completely instead of like the x to the 3rd power. You cannot simplify that any further because the x is a variable and the 3 is a integer. Question C has negative 4, x to the 5th, y to the negative 2. Let's rewrite this out so that we can see all the pieces. We have a negative 4 times x to the 5th times y to the negative 2. So negative 4 times x to the 5th times y to the negative 2. We want to go through here and find anything that has a negative exponent. We have a negative 4 has the exponent of a 1. Always remember that everything has an exponent. That does not have a negative exponent. X has a 5, which is a positive 5. Y has a negative 2. This is your negative exponent, and it's only attached to the y. Now, this 4 is negative, but it's a negative coefficient. This is negative 4, not a negative exponent. So we don't care that it's negative. This does not change. Only the negative exponent will change. So we need to put our fraction bar. The y to the negative 2, currently there is no fraction, so it's all in the numerator. This y to the negative 2 is negative. We're not allowed to keep that. So we move this across the fraction bar. The base stays the same of y, and the sign of the exponent is changed. So that negative 2 becomes a positive 2. That was the only thing that we had to change because this was the only one with a negative exponent. So what stays in the numerator? The negative 4 is a coefficient. Negative coefficients aren't moved and they are not changed. So we keep the negative 4 in the numerator, and we keep the x to the 5th in the numerator. This, we write it out as our final answer of negative 4 x to the 5th divided by y squared. because we're looking for negative exponents. The 2 is positive, the 5 is positive, the 1 is positive. Therefore, we have no negative exponents, and this is our simplified value. And as always, we only have one letter X in the problem. Yes, there are 5 of them, but we only have one letter X physically written, and we only have one letter Y physically written. So those are how we know that we have simplified that completely. On question D, this goes back to that last part of the property where we have parentheses with an exponent outside of it. So on the outside of this, we can use this property where we take the numerator and denominator and completely flip them. So this will actually turn into parentheses. The numerator and denominator flip. Nothing, no signs change inside. We are keeping all of the bases the same. We're keeping everything inside the same, except that the numerator and denominator will flip. So the numerator of x squared will go to the denominator, and the denominator of y will go to the numerator. Now, because things have been moved across the fraction bar, the exponent on the outside of -3 turns into a +3. This is that property where we can just go ahead and flip everything inside, and now the exponent on the outside turns to a positive. Now we use the expanded power rule to distribute this exponent of 3 to every piece inside of the fraction, or inside of the parentheses. So this y has a 1 attached to it, so this becomes 1 times 3, which is 3. So we'll have y to the power of 3 in the numerator. This is x squared to the power of 3, so that becomes 2 times 3, which is 6. So the denominator becomes x to the power of 6. If we look, we have no negative exponents. We have a +3 and a +6. We have the letter y written one time, and we have the letter x written one time. Therefore, this is simplified as much as possible. You could take this original problem and do the expanded power rule for at the beginning, and it would have become x to the -6 divided by y to the -3, and then we would have to make sure that we move all negative exponents across the fraction bar. So numerator to denominator, denominator to numerator. It would have given you the same answer. Question E says this is a product as well, because we have a parentheses times a parentheses. So please remember that you will have to use the product rule as well as the negative exponent rule. So let's go ahead and do the product rule first so that we only have one coefficient. We only have one letter x. We only have one letter y. Let's go ahead and combine everything that we can. First, we're going to multiply the 3 times the -2, which is -6. That is a normal multiplication because these are nothing to do with exponents. These are just normal multiplications. Next, we're going to look at the x's, which is x to the -2 times x to the first. As a reminder, with the product rule, you add the exponents. The exponent of the x currently is a 1 here, so we have a -2 and a +1. We add them. So this is x to the power of -2 plus 1 is -1. Then we're going to do the y's. This is a y to the power of 1 and a y to the power of -3. So when you multiply bases that are the same, you add the exponents. So this is 1 plus -3, or 1 minus 3. This will be y to the -2. These are still all multiplied, so I'm going to put a multiplication symbol in between them. Now we have just one coefficient, one letter x, and one letter y. So that makes it a little bit simpler to now manipulate and get rid of any negative exponents. So we've done our product rule. Now let's do our negative exponent rule. We go through and find any exponents that are negative. As a reminder, this -6 has an exponent of 1. So I'm going to start from the -6. This is not an exponent, the 1 is the exponent. This is a positive 1, so I am not going to move this. The x has a negative 1 exponent. This is negative, so I will move this. That exponent is attached to only the x. The y has an exponent of negative 2. The negative 2 is only attached to the y, so I will have to move that piece as well. So we now know what pieces we have to move. We're going to write out our fraction bar. What did not move? So what did we not touch and stays where it is? The negative 6 is not touched and it is originally in the numerator. It will stay in the numerator. Remember, negative coefficients do not move, do not change. So we'll keep the negative with the 6 because the exponent was positive. The next one we have is x to the negative 1. That was circled. That means we have to move it. It was in the numerator. Now it goes to the denominator. The base always stays the same, but the exponent changes its sign, so it turns into a positive 1. Next, we have the y to the negative 2, which we did circle. This will move to the denominator, so the base stays the same. We'll keep the y, but it turns the exponent from a negative 2 to a positive 2. We have moved everything. We have one letter x, one letter y, positive exponent, positive exponent, positive exponent on the negative 6. So we are still good with that. Now let's rewrite this into our final answer. The numerator of negative 6 divided by x to the power of 1 can just be written as x, and then y to the power of 2 is written as y squared. So our simplified value, or our simplified expression, is negative 6 divided by xy squared. So there are a couple of caution and things to remember. When you're looking at this, what I was talking about earlier is the negative x. That does not have a negative exponent. This does not turn into 1 over positive x. This x has an exponent of positive 1, so it does not move. A negative coefficient does not move. This exact same thing of negative 3 does not turn into 1 over 3. We do say negative 3. We have always used the value of negative 3, so it does not turn into 1/3. You can take 3 steps backwards, and that doesn't turn into taking 1/3 of a step. You can do negative 3. This is a negative coefficient and not a negative exponent. So please remember, an exponent applies to only the factor it is directly attached to, unless parentheses enclose other factors. For example, parentheses negative 3 parentheses squared is really the same thing as negative 3 parentheses times negative 3, because the entire parentheses is being squared, not just the one value. Which turns into, so negative 3 times negative 3 is a positive 9. While we have negative 3 squared, no parentheses. So what is actually being squared? This exponent of 2 is only attached to the 3. Remember, an exponent applies to only the factor it is directly attached to. So it's only attached directly to that 3. There are no parentheses. So what does this mean? That negative on the outside was never touched. So we do have a negative 1 times 3. 3 squared means you write out 3 twice. So we have negative 1 parentheses 3, close parentheses, open parentheses, 3, close parentheses. Because only the positive 3 is being touched with the exponent, we write out the positive 3 twice. So what does this turn into? 3 times 3 is 9, times negative 1 is negative 9. It looks like these problems are the same, but they are not. One has parentheses and one does not. Parentheses are your backstabbing best friends. If you do not utilize the parentheses correctly, it will do the order of operations incorrectly. So please make sure that if you're looking at exponents, if you're dealing with exponents, that you see what the exponent is directly attached to. Don't assume that it's attached to everything, only what it is directly attached to. So this exponent of 2 on the parentheses is actually attached to the parentheses. So if I were to circle this 2 is attached to the end parentheses. That means I have to go to the beginning parentheses as well. Because it's attached to the closed parentheses, I have to go to the open parentheses to finish my circle. Whereas on this exponent of 2, there are no parentheses. It is directly attached to that 3 and only the 3.